how I got from this to this. This project started 5 years ago when I decided I wanted a challenge using my engineering knowledge and machinery, so I decided to build a helicopter of some kind. This was originally sparked some 20 years earlier by a man living not very far away who had built his own helicopter and had attempted to fly it. This captured my imagination and made me aware that doing such a thing was possible. I've always had an interest in flight and knew very little about helicopters, but I was keen to learn, so set about doing research. Of course, the first thing to do was visit the man from decades earlier and learn whatever I could from him. He was extremely helpful, lending me books and gave his knowledge willingly. I came across the YouTube video of the Shuffman Helicopter using a coaxial configuration with microlight propellers instead of rotor blades, and thought I might be able to build that. After talking it over with a man down the road, he said that building longer rotor blades over propellers would be the way to go, and I took that decision on board. Now I had something to start with, I needed to know the answer to a lot of questions. Primarily, how do helicopters fly? I was told that the Western-super-Mare Helicopter Museum was really good, so I went and took pictures, which was a great start. I couldn't take any measurements, but just seeing how these things were put together was really useful and motivating. I found a video of the Nolan coaxial helicopter on YouTube, and this was perfect. It flew so well and looked possible to make with no complicated swash plates. Built by two regular guys in their garage with an automotive background. This is what I wanted to build. The only stumbling block was the specially made reversing gearbox. I wasn't sure if I could make this and thought there must be an easier and lighter way. I then came across the Excavator 2 and noticed they used synchronous belts to drive the reversing gearbox and thought, could one of the belts be used in a figure of 8 to reverse one of the rotors and get rid of the gearbox? I contacted Gates, who manufactured belts, for some design advice. They gave me some information until they asked what I wanted it for. As soon as I said it was for a helicopter, they ended the conversation and said they cannot help in the design of a homemade aircraft. First lesson learnt here, don't tell people that you're building a helicopter, as they won't help due to liability concerns. I then went online and found that you could download Gates Drive Design software. It told me everything I needed to know, including the option of a double-sided belt. Bingo! That was the solution to my conundrum, and all I had to do was use the software to determine the type and size needed. I knew the hardest part of building a helicopter was going to be the blades, but first, questions like what length, what chord, what airfoil, what speed, what material, etc. etc. I collected as much information as I could from working helicopters on engine horsepower, blade length, tip speed, maximum takeoff weight, and compared them to build a picture of what works. There weren't many examples of coaxials to go by, but it was a start. The internet was really helpful here, but with design information on helicopters, it's still not so easy to find when compared to a lot of general subjects. Once you've done as much research as possible and sketched your designs, it's time to start building. I started with the frame as it was the quickest and most fun part, but next time I would probably start with the blades. The size blades you make decide the speed they run at and what they can lift. This sets you gearing and what weight airframe you can build. Anyway, I started with the frame and first built a hydraulic tube bender as I wanted a tubular frame. Box would have likely been easier, but I liked the look of a tube, so went with that. Keeping the weight distribution or centre of mass correct is a constant battle and needs to be checked regularly. I toyed with a couple different ways to join tubes together. I decided I didn't want a welded frame, which would have been the lightest method, but fatigue cracking from the vibration might have been an issue. Having a bolted frame is convenient when making modifications, but does require more work in the beginning. I think for a prototype, a welded frame would have been okay, but bolted was my decision. Having little knowledge of working with aluminium at the start of the project, I actually went for 3mm wall tubing and built most of the frame with this. 3mm was ridiculous, and I could have gone for 1mm still and had the same weight. I changed this to 1.5mm wall, which was much more sensible. I chose an outboard engine because of cost. I paid 500 quid for the outboard, and if you bought an aircraft engine of similar size, you'd be paying 6 times that price. The outboard ticked nearly all the boxes: price, weight, power, and it had a vertical crankshaft. The only downside was how to cool it. I thought it was original in using an outboard engine to power a helicopter, but found it had been done decades earlier. The next challenge was the drive or transmission. I had to figure out how the twin rotor shafts were going to be made and put together. Decisions on what size shafts, what materials, keyed shafts or keyless bushings, what size bearings and type, and I had to make sure it was possible to assemble the design. Certain decisions had to be reversed, realising there was no way to assemble it. I mainly used hand-drawn diagrams, but CAD was very useful for modelling individual parts and checking the weight of those parts. With a bit more knowledge, perhaps some stress analysis could have been done using CAD. Once certain parts were made, I did test them with a torque wrench to physically check they could handle the load they were put under. The hardest part to this project was deciding what design and how to make the blades. The first set of blades I made, I decided not to use as the design was much too heavy. They would have been fine for a helicopter with collective pitch, but mine with fixed pitch, there would have been far too much inertia. I needed to come up with a far lighter design, and I also needed to get the chordwise mass of the blades closer to the 25% mark. This is where the centre of pressure is located on an NACA 0012 aerofoil. You can buy extruded aluminium blades, and this would be the easiest solution, but I wasn't prepared to spend the money needed, and if you just buy parts you don't learn anything. Making them forces you to understand the design of the parts, and who knows, you may come up with a design nobody's tried before. I chose the 0012 blade for reasons of stability. There are other airfoils that can offer improved lift, but at the risk of stability issues. Finding a suitable clutch wasn't easy, but I came across the RK400 centrifugal clutch used on microlights. It could handle the horsepower and torque required, but with an all-steel material used, it was heavy and would need to be heavily modified to fit my outboard engine. I took the decision to make a new cage and drum from aluminium, but I used 7075 T6, being the highest strength aluminium available. There were questions like, will this be strong enough, as the Mini 500 I found out used an RK400 clutch and it broke up during a test. So far it's been okay, and I think that's to do with the addition of the flexible drive coupling. This reduces the magnitude of the engine torque spikes and relieves the stress on the clutch. In the days of the Nolan helicopter, with no internet, the brothers' success was remarkable. Going back further, and the pioneers of helicopter development with little to no previous knowledge to go by were truly amazing people. If you consider all the physics of what is going on in a helicopter in order to make it work, as a pioneer you will be constantly thinking the likelihood of all this actually working in the end is very small, yet they persevered. Even I, with all the knowledge available to me, have stopped along the way thinking it won't work and I should stop wasting my time and money. You have these doubts by yourself sometimes, but you also get other people telling you it won't work or you shouldn't be building such a thing. I've actually found though that these doubts, although they can be highly demotivating at the time, turn into a positive outcome. Being questioned makes you double check your work and pushes you to understand what you didn't bother to understand before. Having doubts and being questioned is part of the process, and it can help lead to success. Something I also learnt along the way is that even if the project failed to fly, what I had to learn or understand to get this far would have been worth it. In building a helicopter, there are much more design decisions to be made when compared with making something that doesn't fly. In past projects, if I wasn't sure if a part was going to be strong enough, all I had to do was over-engineer that part. In a flying machine, that isn't possible. Everything needs to be made as light as possible while keeping the safety factor. This takes knowledge, and a lot can be done with experience, but to build the lightest possible machine would take a monumental effort. I have had to rely on some experience in areas, as I don't have the intellect to go into the depth needed for the lightest helicopter possible. This means my machine won't have the best performance, but the goal is to build a helicopter that can fly. What I build after this, I don't know. Jetpack, Ekranoplan, flying saucer, who knows? But the knowledge gained building the helicopter will no doubt make the next project all the more possible.